In 1899, Santa's workshop would have been in mainland Canada. Specifically, it would have been in the far north on the Boothia Peninsula. But then, in 1992, Santa's workshop would have moved 575 miles away to Ellefrinus Island, also in the far north of Canada. Well, okay, not really. Santa's workshop is said to be at the North Pole, and this is the geographic North Pole, or where the latitude lines reach 90° north, and the point where the imaginary axis of rotation comes out of the Earth's surface. So then why did I talk about Santa's workshop being in Canada? Well, that's because I was talking about a different North Pole, specifically the magnetic North Pole. The magnetic North Pole marks the spot where the magnetic fields head straight down back into the Earth. A fun fact about the North Magnetic Pole on Earth is that it is actually the south pole of the magnet. We just call it the North Magnetic Pole because it's in the northern hemisphere. What this means is that magnetic material will get attracted to the North Magnetic Pole, and this is how we have compasses. This means that if you were standing at the geographic North Pole, the compass would instead point to the North Magnetic Pole. The North Magnetic Pole and the geographic North Pole are not even the only two North Poles. There's also the North Geomagnetic Pole, which is mostly a theoretical concept that's also based off of magnetism. But let's go into the topic of today's video, and that is magnetic polar wander. So over time, the magnetic field, and thus the magnetic pole of Earth shifts. This is known as magnetic secular variation, or specifically to the pole, magnetic polar wander. Now, we shouldn't confuse magnetic polar wander with the two other types of polar wander. There is both apparent polar wander and true polar wander. However, these both describe how the Earth has moved relative to the poles, and not how the pole has moved. But if you do want to see me cover these in a video, let me know, and I might get to it eventually. So what is the process that causes this geomagnetic secular variation? Well, to find out, we have to look under the surface of the Earth, specifically in the core. Here is the core of the Earth, and it is split up into two different sections, the inner core and outer core. Now, both of these sections are made almost entirely of metal, primarily iron and nickel. The core is extremely hot, which means a lot of it is liquid metal, except the inner core, which is under immense pressure. This liquid metal is the exact process that creates the magnetic field of Earth. The name of this process is the geodynamo. In this outer core, we have convection currents. Basically, metal that is closer to the boundary of the mantle and the outer core is cooler, which will cause it to fall down towards the inner core, but then it will get heated up as it falls towards the center and start rising out towards the mantle again. This process creates a magnetic field because it aligns the metal into coils, which are necessary for creating a magnetic field. But why doesn't the magnetic field stay consistent like it would in a normal magnet? Well, it is due to the fact that our Earth is a very complicated place, and there is a lot that interferes with the magnetic field. Specifically, the process that changes the magnetic field is known as flux lobe elongation. Yes, I guess when you get to this section of the Earth, the names start getting extremely futuristic. So what is flux lobe elongation? Well, in a normal magnet, you have what are known as flux lines. These are the lines that magnetic material will follow in an arced pattern, and they are present in our Earth's magnetic field. However, since the Earth's interior is such a complicated place, these flux lines actually get entangled with each other. What this entanglement of the flux lines does is create what are known as flux lobes, which are areas that have a lot of those flux lines emanating from and are thus very strong magnetically. Specifically, there are two flux lobes in our northern hemisphere here, the Canadian flux lobe and the Siberian flux lobe. These two lobes essentially play a game of tug of war with our north magnetic pole here. If one side is stronger, our magnetic pole will drift towards that lobe. So this explains why the pole is shifting. As you can see in this diagram, in 1999, the two lobes were roughly the same size. The Siberian lobe was slightly bigger, which explains why the pole was still moving towards it, but they were roughly the same size. But then, in 2019, something shifted in the core, causing the flux lines around the Canadian lobe to get elongated. This has effectively decreased the energy of the Canadian flux lobe, causing the north magnetic pole to rapidly move towards Siberia. So now that we know how the pole has moved, let's look at how it has moved in the past and how it will move in the future. Here is a great map showing how the north magnetic pole has moved since 200 AD. Each of these red dots are 50-year periods. Now obviously there was no observation of the poles actually being here until 1831 when it was first observed, but this data has been compiled from paleomagnetic evidence. This magnetic pole has moved all around the northern hemisphere. It has moved from Siberia in 200 AD to above Russia, getting very close to Norway. It has even crossed over Svalbard in the past and Greenland. It has gotten extremely close to the geographic North Pole, and then it finally went towards Canada, where our first observation of it occurred. Then, until 1831, there wasn't another specific pinpointing of the pole until 1904 and then 1948, which confirmed that it was moving north. And ever since then, it has been rapidly moving north. In fact, it has accelerated towards Siberia, again due to the rapid shrinking of the North American flux lobe. From the 1700s till the end of the 1800s, it moved at just around 6 miles per year. However, in the year 2007, it traveled around 34 miles in that 1 year. This definitely makes it one of the fastest moving global changes on Earth. It has slowed down since its top speed in 2007. However, it still travels around 20 miles every year. In 2017, it also crossed into yesterday, or it crossed the international date line. And today it is still drifting in the Arctic Ocean, getting closer to Russia. But that also begs the question, will the pole ever reach Russia? Where will it go in the future? Well, it is really hard to say. Since the processes that change the magnetic field happen in the core of our Earth, it is extremely difficult to predict how it will change. It's very possible that the Canadian lobe grows again and we see the north magnetic pole go back towards Canada. It is also possible that the Siberian flux lobe keeps growing and we do see the pole eventually reach Russia. And with the rate that the pole is traveling at, we do not have to wait that long. So that is how the magnetic North Pole has shifted over time. And while this may seem concerning, there is no reason to worry. The only thing this really changes is navigation with a compass. So airplanes have to be recalibrated every so often. And, as you probably saw in that one CGP Grey video, airport runway numbers also need to be changed. But maybe it's a good thing that Santa has his workshop at the geographic North Pole, because otherwise he'd have to be constantly moving his workshop. Thank you all for watching, and Merry Christmas.